No, bro. It's 19. If you didn't do it, you need to do 21.1 and 2. If you didn't do it yet.
Can I just use my math notebook?
Yeah, totally. That is paper, right? So, because I'm sure at least one person is curious, and probably more than one person. You guys remember St. Patrick's Day when I told you about my tattoos?
Yeah.
This is Abby, my niece. So, she's here visiting for spring break. You're in 6th grade, right? Charging you practice. So she's not really doing 7th grade math yet. She's just hanging out with us. So yeah, Abby, this is my accelerated 7 class. What's up? Oh, other Abby, actually. So this is Abby too. Abby. What's up? What do you need?
They're not ours. They're the seven.
I'm okay with her not reading. We'll get that figured out. That would be wonderful for her, I'm sure. So, this morning we went over all the tools. You don't need one of those, Ozzy.
I know, but I would want to see one.
Okay. Well, make sure you give me half of your attention.
Okay, I will.
I've got a really fancy one of those you can play with whenever you want. It's a color one. So if you ever want to play with a graphic calculator. This morning we looked at all the tools, but now we want to go through and review these questions. I'm planning to get at least through problem 12 today. Tomorrow when I'm not here, because we're getting a new roof put on our house, I need to be there, or some construction. Tomorrow I'm not here. You guys are going to be on computers, at least hopefully. I have not reserved them yet. You're going to be working through the rest of whatever we don't cover today. And then Friday, we'll review any questions that you have. Like, we'll go over the answers and take any questions that you have. And Monday's the air test. You guys are ready. You're more than ready. You're completely, totally ready.
Really?
Yes. So you have no reason to be nervous. There's this Will Smith video circulating around about how, like, the best moments in life are on the other side of intense fear. The air test is not a best moment in life, and it does not deserve your intense fear. You have nothing to be nervous about. So let all your nerves go. You're ready. When we talk about overlapping data sets, this takes us back to chapter 15 when we're comparing data sets. Now what, this might be interesting reading on their web player thing. Sorry, it's rude to talk over people, so I was going to wait for you. Let's see what I did there. So, we're looking at which of these data sets has the most overlap. Now, what you have to pay attention to is their data sets are stacked. I wish they would use, like, X's and O's or something that, like, you can actually see them on the same number line. You have to imagine if this was on the same number line. If this was on the same number line. Like, where is there the most amount of overlap? So, Monica, what do you think?
In D, because if you put them together, then all the way from 2 to 10, there's overlap. And that's much more overlap than anywhere else.
If we look at like how many points overlap, yeah, here we have 8 points of overlap. We could look here. We've got 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8. But there's only 7 from here, so we only get 7 points of overlap.
But how can you count them all as overlap since there are only 2?
Okay, so, well, they're in the same general location, so the sets are overlapping. So if you look at, like, heights of 7th graders and heights of 8th graders, they don't have to be the exact same to be overlapping.
Oh.
So, like, if one set, imagine if we did curves for this. If one set was curved like this, and the other set, let me change colors, is curved like this, then if I drag this up, you can kind of see the overlap. So there's still a lot of overlap here, but there's really no curve down here for the overlap. So it would be like that, and then that, and they're the same. So then if I compare in A, well, none of those overlap, none of these overlap, just these parts overlap, and it only involves those 3. And actually the 11 is not even involved, so actually, sorry, it only involves those 2. Now set B is
Why are you
interesting.
only counting the ones on the bottom? Should you count
we got to look at overlap. So like, where are they, like both sets?
Oh, where's the least?
We're looking for most. But
No,
oh yeah. So which set, like how many values of the set are overlapping with the other set?
Yeah.
So there in my whatever my lower set or whatever you want to call that, only 2 of those points overlap with this part of the data. But again, I hate how they split the graphs here. So D, because they are pretty much exactly the same. And I don't know if that sort of thing will be on the actual test. Try to make some kind of rationalization for it. Like, what could this actually be representing? Like, number of pets in your house. And they ask McCord and Kilborn. Or sure, yeah, like try to give it some realistic data. So a triangle has a side length of 3/4 of an inch and a side length of 3 inches. What could the length in inches of the third side of the triangle be? I definitely wanted to review this
Yeah, I didn't
because
GeoGebra?
just so I can show you guys.
Couldn't there be a lot of different answers for that? Besides geometry.
So I want to make a line 3/4 of an inch. I'm just showing you guys this on here just to. So guys, come on. So 0.75, 3/4 of an inch, and then well, I guess I'll have to go 3.75. And then approximately here. So if I make a triangle, I need a third line, right? So let's connect A to C. Yay, triangles!
Yay!
No.
No,
It's a line.
it's a line. How do we make it a triangle?
The third one has to be longer than both.
Yeah.
So I have to move one of my points, right? But I can't make it shorter, actually. Actually, this is getting too hard. So let's just play with it on there. You make a short line. 3/4 of an inch. And you make a little bit longer line. 3 inches. I hope this is going to let me do what I want to do. I can't make a triangle until I move one of these lines. And when I do that, that has to stay connected right here. So what happens to the distance between this endpoint and that endpoint as I rotate this up?
Gets shorter.
It gets shorter, right? So the shortest it could ever possibly be is when it lays down and makes the triangle as small as possible. And if that blue line is 3/4 of an inch, at what point would this stop being a triangle?
When it touches the line. When it becomes 180 degrees.
Well, yeah, when it hits the bottom, when it becomes 180, all the things people are saying. But what would the length of this be when that flattens out into a line?
3/4 minus 3 inches.
So 2 and a
2
quarter, right?
2.
Yeah.
Well, that's 3/4, and that's so not where it is right now. But if it was on the line flat and they had connected, that would be 2 and a quarter. But that's not a triangle.
It's not.
It's a line.
It's a line. So if it was flat, but as soon as you lift it up, this line now is more than 2 and a quarter. And as it rolls and it rotates over to the side, then if it was like right here, then my connecting line between them. Guys, stop with the noises. I don't know at what point we decided that was appropriate, but it's not. Once I get longer than that, now I'm bigger than 3. And what's the longest with that 3/4 of an inch side? Well, where would it stop being a triangle? How long would that connecting line be when it's not a triangle?
3 and 3/4.
3 3/4. Because if I went all the way, my 3 inches and then my 3/4 inches. Do you need to move? Okay, move. That would be 3 3/4, but it's not a triangle. So I'm restricted. The shortest it can be, and well, the shortest that it can't be, because there's no equals, is the difference. The longest, but it still can't be that, is the sum. So what we do to set up that inequality so what you're going to want to do here,
It doesn't have the right symbols.
what could be the length in inches of the, oh, they're not even making you do the entire range. This is way easier than what I thought. It's just asking, what could it be? So imagine if you have a line that is 3, and then you have a line that is 3/4. Will this connecting line be more or less than 3?
More. Wait,
No,
less.
Yeah, imagine if you rotate it down. Could it be 2?
Yeah.
Maybe? No, wait, no, it could be 2 and 4.
Remember your triangle rules. The sum of any 2 sides must be bigger than the third. So when I add the 3/4 with whatever I make this, it's got to be bigger than the 3s. But if you make it 7, it's too big, because 3 and 3/4 is not bigger than 7.
2.26.
So we could make this 2 doesn't work, get bigger. Would 2 1/2 work?
Yeah.
2 1/2 plus 3/4, is that bigger than 3?
Yeah.
This picture may not be right, but this could be 2 1/2, and that would be fine. Could it be 3?
No. Yeah.
What if you turn the triangle? You're just changing your answer because I made a face. What is a triangle with 2 sides the same length? Isosceles. Could the bottom of this be 3/4? Yeah! Why not? You people are saying no without even thinking. You have to figure out a reason why it wouldn't work. You're just saying no because I'm asking the question and you think the answer is no. Stop answering without thinking. So, this is not as hard as I thought it was. I thought it wanted the double inequality. It just wants an option. So you could use 2 1/2. You could actually use 2.3, 2.4, 2.5, 2.6, 2.7. You could use everything up to 3.74, essentially. Because at 3.75, that would not be a triangle anymore. Because they cannot equal.
Aren't there infinite possibilities?
No.
Because you can keep putting decimals on.
Okay, if you look at continuous, there's an infinite amount of numbers between 0 and 1. So but here they want in inches, and I doubt they're going to want a million decimal places. So no, I'm going to go ahead and say no for this problem. There's a list of choices that will work. Now, theoretically, there's infinitely many possibilities.
I wish you graded our test.
Yeah, 2 1/2 would work, 3 would work, 3 1/4 would not work. That would still work. 3 1/2 would work. 3. So where it stops working is at the sum of these. So you cannot go past their addition. You can't even use the addition. You got to be between. You got to be between their difference and their sum. That's really all you got to know. So I would write down for triangle side length has to be between difference and sum. So are you writing that down? Write it down. Triangle No. You will not be able to have it on Monday. It is a study reference. Triangle side length.
So for the real test, are they gonna have questions like this just with different numbers?
I have no idea what's on the test. So, if you were writing the inequality, it doesn't want this, but it would actually be 2 1/4 is less than the side length is less than 3 3/4. And you'll learn how to do that really in 8th grade. You'll learn how to technically, we did a little bit of that this year, but not enough that you're fully confident on it.
Typically, the questions are really similar to the actual ones of the test.
Yeah, most normally, but I don't want to like tell you guys something and then it not be true. So I'm not certain. Question 3. Now what's funny is a lot of times with these number lines, they'll give you scale and here they did not. So let's assume scale, and then if that doesn't work, we can change. What would be the safe assumed scale?
1,
1, right? 1 tick is 1. So B is at what?
4.
-4. So the first thing you identify, and I would write this down on your paper, is B is -4.
This one was really easy.
So
Easy.
what I'm given is A minus a -4 is C. What you make A makes C.
But A has to be negative.
And C
Oh.
has to be negative. So that's the problem. A determines C, or if your math is good, C could determine A. So Jeremiah, where do you want to put C?
I wouldn't put it at negative, or not. I would put it at -7.
It doesn't matter where you put it. That's fine,
Put it
sure.
at -7.
-7. 1, 2, 3, 4, 5, 6, 7. So now what my inequality or my equation would say is A, and we can go ahead and replace that with A plus 4
Because mine is
equals
negative.
-7. Now here's the problem. Your number line only goes so far. So while I can do that, now when I solve for A, Ozzy, how would I solve for A here?
So, can I just tell you what to do for the rest of the problem?
How would I solve for A here? Yeah.
Well, you just, oh yeah, you have to, add 4 and -7. So
Not
you
quite.
But
Yes.
You have to cancel 4, so you subtract 4 to get rid of 4.
Inverse operation, we subtract 4. Now I agree. Mentally, you're adding them to get 11. But what we're doing is subtracting 4, and we get -11. So A, if I made C -7, would need to be -11.
You're 1, you don't have that last.
There is no -11 on this number line. So this doesn't work. Mathematically, it can work. On here, it does not. So, Jeremiah, while you really can place C wherever to start, but now I realize I can't place A now. So how would you edit C to try to think like,
I like to put, what I do, I just put A first and then I do C.
so we can try that, but remember C has to be negative. So Andrew, how would you edit C?
I put A, I put A on -3 because because A minus.
That won't work.
Dang it,
Guys,
I had-
when it tells you that C must be negative, I would advise you to start with C being negative. But we saw we were too far negative here. Jeremiah, how can I compensate?
Well, is there another way to do it? Because
There's always multiple ways to do it. So that's
then
not
I
even
think
really a
that
question.
I think that A would go at 0 because A minus plus -4
It's
is
not plus
-7.
negative.
Oh, okay.
It's
well, isn't B negative?
minus negative.
Oh, so then you would have to go up because a negative minus
So
a
if you
negative
put
is positive.
A at 0, what's 0 plus 4? 4. Does that make C negative?
No.
That doesn't work. So again, I would place A first. Or sorry, I would place C first, but -7 didn't work. It was too negative. Ozzy, how would you edit?
Alright, so I put the C on -6.
Let's bring it in one.
And then
See,
I-
does that work?
Then I put A on negative.
So, plug back in what you got. We put it on -6 now. What is -6 minus 4? -10, which makes A equal -10, and then I can drag it and put it there. All we needed to do was bring A up 1, so take C up 1. Be careful, because you gotta have C negative. Now you could place A first, but if C comes out to not be negative, it doesn't work. And be careful to minus the negative. Notice they did that intentionally. They're trying to get you to screw up.
That's not really
A negative plus a negative is a bigger negative. But that was negative, that was minus a negative, which turns into plus positive. Yeah, so be careful, make sure you got those rules straight. Two quantities A and B have proportional relationships. A is -4 when B is -3. Create an equation to represent this. So proportional is it goes through that origin. Hey, Moon, can you get up, please? You almost got it. If you sleep in my class, you don't want to sleep in my class.
No, are you gonna go on their face?
No, that's just rude. Sorry, I turned this off.
Well, you do that.
Don't worry about it.
I want to find out.
Oh, Mr. Hudson, did
Yeah.
you take your heart out?
No.
Someone go to sleep.
So guys, we are relating A and B. And when A is -4, B is -3, what else do we know? Because it's proportional. A proportional relationship. If you think about like if you did it on a graph or something, we saw one of these this morning. Monica?
That I was gonna say that B would be 1 more than A always, but that's not true because if you multiply it, then
Proportional relationships. When we talk about something being proportional, Andrew, if we were to graph it, do you remember what the graph would have?
It's like greater or less than. What the graphing is like. Oh, like what we do.
If I say that I have a proportional relationship with a room that I'm painting and cans of paint that I need, and the room is like a perfectly sized room, it's square, all things are the same, like all the walls are the same, and I tell you, I need a can of paint to cover 2 walls. How many cans of paint will I need for 4 walls? 2. Because if 1 to 2 is the same as 2 to 4. That creates, well, how many cans of paint would I need for no walls?
0.
None. We start at the origin and we have a straight line.
doesn't it mean
Now,
that
they tell us -4, -3. So, I'm at some point that goes to -4 and -3, but I've now made this is my A-axis and this is my B-axis. But I just wanted to remind you how proportional relationships work. So I would jot down on your paper really quick, make a graph, straight line through the origin, and you can abbreviate it, PROPREL, proportional relationship, straight line through the origin. So what they're saying is when I plug in an A of -4, my B spits out -3. So my B will be something with my A. And when I plug that in as -4, this becomes -3. This uses inverse relationships, or reciprocals. The other thing, and this is going more into 8th grade standards, when you look at making the equation of a line, it's real easy. And you guys have done a little bit of this in science. You guys have talked about slope, right?
Yeah.
The slope of a line is what describes its equation. And the slope, I don't know how to find slope. Who can tell me what fraction?
Delta X.
Change. So it's rise over run. Change in y over change in x. That delta is change. So I don't know what's my change in y over my change in x. Or I can do change in y over change in x. What's my change in y here? How far down did we go?
-3.
-3. How far did we go with the x?
-4.
-4. So my slope is -3 over -4. What's a negative divided by a negative?
A positive.
Positive. That slope becomes 3/4. Now check it. What then happens when I plug in that -4? Well, b equals 3/4 times -4. Well, I can put that over a 1. What's a positive times a negative?
Negative.
Negative. The 4 on top and bottom,
1.
they make a 1. The 3 on top then gives me my answer of 3. So even though they use A and B, I don't care. Use whatever you want. You can set that on a graph and make them X and Y instead of A and B.
I'm confused
How so?
with the graph bit, like what you did down there with the b equals.
So we've been told this, that when A is -4, when we're at an A value of -4, when we've input -4, the output, the B value, whatever, becomes -3. And we know it's proportional, which tells me the graph. If we didn't know that this was proportional, this would be very hard to solve. We could not solve it without one more piece of information. This is my one more piece of information. So what I also know is when x is 0, y is 0. Or when A is 0, B is 0. Because it's proportional. So that's what that origin point tells me. So then I can make a line that represents that down to the point I know and figure out that line's slope. Well, if I want to go rise and run, if I want to go up and over, I go up by 3 and over by 4, and my slope is 3/4. So you guys did that a little bit through science. We can also just set this up, like the way that we could start this, knowing that we have this relationship, is A over B. So that's -4 over -3. But then we need to know another, like, we can't set up a proportion here because we don't have another value. Know what I mean? So that's the issue, is we don't have another value here to determine what it is.
So is the slope?
But, so, they just want the equation. You're not trying to find an answer, you're trying to write an equation. So, if I set this up, let's choose an A input. What about when A is 1? Because that's easy to work with. So go ahead and throw this on your paper. The A over B equals -4 over -3. I'm going to capture this and then probably clear it and start this over. So you should have, you were told an A and a B, a -4 and a -3. They don't give me another B value, but I can choose one. They don't give me another A value, but I can choose one. I can't choose both. I can only choose one of them. Well, I'd like an equation that's either A equals or B equals. So, if I want to get a B equals, plug in a B, where my B's go, and choose an A. Easiest A to choose would be 1, because 1 doesn't really do much of anything. Now we can cross multiply this, and we see that 3 times 1 will equal -4 times B. This now becomes the algebraic equation that we're used to working with. Sorry, this was -3. Make sure you have that negative. Don't forget that. how do we isolate
Wait, why?
B here? Andrew? Divide. I mean, we are getting rid of it, but how we do it is dividing by -4. And then we get that B equals 3/4. And that's when the input of A is 1, which tells you the slope. When your input is 1, your output is your slope. So this is another way that we can get our slope. Here's the dangerous thing, though. That's not your answer. Your answer is that B equals 3/4. We had input in A of 1. Is A always 1?
No.
No. So instead of using that input of 1, we're going to use any input of A. So what you would need to type in there is that B so you can see it typed. You'd say B equals 3 divided by 4. Hit the right arrow to get out of the bottom of the fraction, and then A. And you can use the multiplication if you want, but you would not have to. Any questions?
So why did we say B equals instead of like A?
If you wanted to do an A equals, you just set up that proportion.
Would either work. Like A equals 3/4 times
No,
B.
it'll be a different slope. So if we set up again that same proportion we just had, I'm going to work over here because it's easier for me. A's over B's, -4 over -3. Now instead of choosing an A, choose a B. Easiest thing to work with is 1. So if we plug in a 1 for B, then I don't know what my A is yet because I can't choose both. So now I get -4 times 1, which is -4, equals -3 times A. I then isolate A by division, and I get A equals 4/3, but that was with B of 1. So A would have the inverse relationship. It's 4/3 of B.
Oh, okay.
So either of those is right.
Wait, so if you find one of them, the other is just the inverse?
If it's a proportional relationship, yes. If I need 1 can of paint for 2 walls, I can paint 2 walls with 1 can of paint. So I can say it 2 different ways.
It's a lot easier to do than I thought.
Yeah, so you can just set up a proportion where you plug in 1, and then that's how you're going to get that relationship.
We have 8 more questions to go.
We've got tomorrow and Friday. It's fine. I mean, yes, you're accurate, though. So which group's observed frequency of being selected is closest to the expected? Now, what's frequency mean again? Yeah, Dom?
Is it how often something occurs?
Yeah, often something occurs. So, they had 4 groups, equal size. They were red, blue, green, yellow. Each day, Larkin selects 1 group at random. Now, if there's 8 days and 4 groups, how many days would you expect each group to be selected? Colin?
2, because you equally distribute the amount.
Yeah. If it's fair, every group would go 2 days. Thomas, which group is closest to expected? Green. Green goes twice. Blue goes like 5 times. Red only goes once, and yellow lucked out. They never went.
That seems fair.
If yellow group didn't prep, I'm sure they're happy. So, I mean, the frequency is not hard to figure out. Take how many total occurrences there will be divided by how many options we have, and I think you guys already know this math, and that's how many we expect. If I have 8 cookies and 4 people, if I'm fair, everybody gets 2. But I'm not fair.
But you'll share with your favorite student.
I'd share it with Abby. I don't know if I'd share it with you, Dom. So, this one, going back to cross sections. Cross sections are those 2D slices through the shape depending on which way I cut. So if I cut parallel to the base, same direction as the base, what shapes can I make?
Square.
Just squares. The base is square, every horizontal cut will be square. If I go perpendicular through the apex, easy enough to grab this.
Parallel and perpendicular are horizontal.
No. Well, so it depends on what you were parallel to. Like, if I'm parallel to the base and then perpendicular to the base, then yeah, they are making, in this situation, horizontal and vertical, but they don't always do that. Because if I do this, then parallel to the base is not horizontal anymore. You know what I mean? So be careful thinking that. Perpendicular to the base through the apex, that's important. What shapes would we get?
Triangle.
Triangles. What if we go perpendicular to the base, not through the apex? Some kind of weird shaped trapezoid. And I can change what kind of trapezoid I get depending on the angle, but it wants perpendicular, so those are going to be a bit simpler trapezoids than it could be. But you could still get trapezoids even if you change the angle and you're not perpendicular. This is a trick question. Everybody that sees it wants to immediately say 2. Because juice is 2 of water, right? But look at what it asks. How many cups of water are needed for each cup of juice? If you want to make 1 cup of juice, this J is not immediately 1. That J is the output dependent on W. So if we make J 1, what would W have to be? No. 2 times what gets you 1 cup?
Oh, 2 times.
You have to do what?
It's a half.
2 times
Oh!
That's why this is a trick. People immediately quickly think like, oh yeah, 2. There's a 2 in the problem. No. That cups of juice equal 2 times as much water as you use. So if you've ever made like juice that comes in the frozen canister and you like dump the canister in and then you get water,
Oh, that's so good.
so my 1 cup of water actually would make 2 cups of juice. If you plug in a 1 here, and this is how you can check it, 1 cup of water spits out 2 cups of juice. I don't want 2 cups of juice. I want 1. So that's where this would have to be a half.
Wait, but how do you know whether that's 2 cups of water? I'm confused because that's
This
2.
is not 2 cups of water. This is 2 times your cups of water.
Oh,
Cups of water is W. That 2 is just a multiplier.
so how do you know when the 2 is the number is just a multiplier?
The numbers are always just numbers, unless they tell you what they are. So my variables are the things that have, like, classification. Be careful with those problems. Think it through, set it up, and check it multiple times. Because if I plug in, like, 3 cups of water, I get 6 cups of juice, and that should kind of, like, spin my brain to say, okay, I'm getting more juice than I put in water. I need less water than the juice that I want.
But here you're imagining that you're not using the lemon.
This one, they have many answer choices that could work. However, they all would need to work together to make the total change a drop of 15. So, what total change do we have so far? How do we figure that out?
We need to add all of them.
So we got a positive 7, a negative 12, a positive 2, and a positive 1. This is not part of your changes. That's your total. They don't do any extra indicating or bolding or coloring. You got to pay attention. That's your total. That does not go in with these. Well, I get a positive 10 and a negative 12. Right now, we've got a loss of 2 degrees with 2 unknowns. How much more loss do I need to create? Andrew? 13 more loss. Split between these 2 days. So, if I make this a loss of 10, what would Thursday need to be? A loss of 3. You need to make the total changes a loss of 15, or down by 15, decreased by 15. When we looked at what we had to start Monday, Wednesday, Friday, Saturday, we had a total loss of 2. But we've been told the total change is negative 15. And notice they use Columbus. We're like one of the biggest cities in the nation. Questions? And we are the state capital for Ohio. And since
But
this
could
is
you
the
like
Ohio
split it up
test,
any other way?
you can. You can split this up negative 3, negative 10, negative 7, negative 6. I mean, any 2 values that will add to negative 13. Because what the test is going to do is put those together and see, did they make negative 13?
What do you need a loss of 15? Like, why is it?
So, think about fall into winter. From the average temperature of Sunday to the average temperature of next Sunday, it's probably going to be colder as we're getting into winter. So if you looked at last week to this week, now currently we're getting warmer. So we're gaining temperature as we go week to week. Their week to week have lost 15 degrees. Like in 1 week of tracking, and they don't even have Sunday here, but in 6 days of tracking, they lost 15 degrees in total.
That's not good.
Yeah, it's getting cold. So it might just be changing seasons. Don't know. For 9, square is shown. It tells you what it is multiple ways, by the right angles, the congruent sides, all that stuff. Perimeter of the square is represented by 16x plus 24. Willa wants to write an equivalent expression for the perimeter that shows the side lengths.
Wouldn't it just be that expression divided by 4?
If we look at perimeter of a square, how would we find the perimeter of a square?
Adding each side.
Easier than that, though.
Multiply by 4.
Yeah, take a side length and multiply it by 4. We are then told, well, that comes out to equal 16x plus 24. So if you wanted only one side, you just divide by 4. Here's what people get screwed up on, though. We're dividing all of this by 4. So the 16x gets divided by 4. And the 24 gets divided by 4. This becomes 4x plus 6. A lot of people will accidentally just do the division with the x value, and they'll keep the 24. You're dividing everything. Check your work. Plug that in for one side length. And see, does it come out when I add up 4x, 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 6 and 6 and 6 and 6, I get 16x plus 24.
Wait, so when you answer a question like that, do you answer it with the 4x plus 6 or with the whole division into it?
Create the expression that Willa would want to represent the length of the side. They only want an expression, they don't want an equation. Expression has no relationship symbols. No greater than, no equal, none of that. So you're not going to use these. Even though they have them there, they just want an expression. So this is all that you would type, 4x plus 6.
But wouldn't that still be an expression, the 16x plus 24 divided by 4?
Yeah, but so this would work too, yeah. But you don't show all of this.
Oh.
So I thought you were asking about showing
so you
problems.
showed this.
Yeah, if you showed this, it's the same, but they want most things simplified. So my advice would be use the simplified version.
Okay.
Team, let me
We'll
see.
pick up on question 10 on Friday. So tomorrow you guys are going to be working through this stuff, writing down your answers on your own.
Team,
There's no more. There were some down the bottom.